Alright guys, let's wrap up this study guide that we started on yesterday. So we're going to look at the last few problems on this one. Hopefully you guys remember the test is tomorrow. I expect you guys to do really well. You guys have been doing an awesome job being prepared for this test. We've done a lot of hard work. So let's knock it out of the park tomorrow, okay? Alright, so the first problem we're going to look at, let's finish up. We're going to write this number 0.00008754 feet in correct scientific notation. Well, remember to do that, remember to make sure the coefficient has to be greater than or equal to 1, but less than 10. Or remember, in my base, what is my base? My base must be, let me rewrite this. Sorry. The base will always be 10 in correct scientific notation. So before I start this one, we know the base is going to be 10. Alright, remember we also learned a shortcut with this one. If I make sure that I have one number that's a non-zero to the left of the decimal, that will take care of my coefficient being greater than or equal to 1 but less than 10. So if I do that, to make it greater than or equal to 1 but less than 10, I'm going to move my decimal right here between the 8 and the 7. That satisfies the rule of being one number to the left, greater than 8 but less than 10. So my coefficient will be 8.754 times 10 to the something power. Well, if I look over here, I notice this number is a very small number. It's less than 1, so I know my exponent is going to be a negative exponent. Now all I got to do is count. How far is it from this decimal, where it started, to where I moved it to? Well, if I count 1, 2, 3, 4, 5. So my number is 8.754 times 10 to the negative 5th feet. Alright? Alright, so that's looking at scientific notation. Just remember this rule and you'll be fine. Base 10, coefficient greater than or equal to 1 but less than 10. Alright? Now we have the same question. Look at this next one. I'm looking for square roots. Same question as 4 different ways. Okay, remember with these problems, if you see the square root symbol, all I want is the positive answer. Alright? But if you do not see the square root symbol, I need both the positive answers. Okay, I'm sorry, both the positive and the negative answers. Okay, so you'll see it sometimes as plus or minus, or plus and minus. Okay, so the first question, what is or are the square roots of 36? I don't see a radical sign here, so I'm going to see plus and minus 6. Remember guys, you'll see it sometimes like this, plus 6 and minus 6. Alright, same question, all I did was take out the word r. Doesn't change anything else, it's still plus and minus 6. The next one, what is the square root? So this is words mixed in with the radical sign. Well, I see the radical sign, so it's just the positive 6. Alright, the next one, x squared, some number squared would give me 36. Really what this is asking is what number can I multiply twice times itself to get 36, or what is the square root of 36? Well, we know the square root of 36 is 6, and I don't see that radical symbol, so it's plus and minus. Because plus 6 times plus 6 is 36, and negative 6 times negative 6 is 36. Okay? Alright, this next one, again, you guys are going to have a calculator. You're not going to have to do this by hand. But remember, we did talk about a little bit about making this by hand, by making these exponents have to be equal to each other before I can do some subtracting. Well, if I look, negative 10 is bigger than negative 12, so I need to adjust this decimal, or this exponent, to make it equal to that one. So I need to move it 2 places because this negative 10 is two places bigger than the negative 12. So we're going to move it 2 places. Okay, so this becomes 0.00874 times 10 to the negative 10th power, because we've adjusted it, right? So that means I had to add 2. Alright, so let's make sure. So if I start right here, 1, 2, uh-oh, I did 3. Let's back up. Let's fix this because I added too many, didn't I? So we only need to move it 2, didn't I? So if I move, I go, here's 1 and here's 2. So I always go back and count. You see how you can easily is to make a mistake. So what I have is 0.0874 times 10 to the negative 10th power. Now I'm going to subtract that from 4.97 times 10 to the negative 10th power. Alright, so I'm going to write this one first since it's a little bit bigger. So 0.0874 times 10 to the negative 10th power. I'm going to subtract that from 4.97. Okay, well, I need to do some filling in here, so I'm just going to add some zeros, all right, behind that decimal. Well, remember with this, we keep the base, so my base is always going to be 10. We keep our exponent. All right, now we can do some subtracting here. Well, I need to do a little borrowing. This is going to be 10. I'm going to borrow one to make it a 9. This is a 10. So 10 minus 4 is 6. 9 minus 7 is 2. 6 minus 8 I can't do, so we got to borrow one to make that 16. 16 minus 8 is 8. 8 minus 8 0 is 8. Bring down my decimal, and then 4. So my final answer is 4.8826 times 10 to the negative 10th power. Okay, so again, remember, you don't have to do this by hand, but I just want you to make sure you can do this because we did look at a couple. You can do that. All right, next one we're going to multiply scientific notation. Well, this is the same rules. It goes all the way back. All I'm going to do is look at my coefficients. I'm going to multiply them. And if I'm multiplying, I know I have to keep my base, and I'm going to add my exponents. Okay, so let's see what 5.3 times 4.2. So 5.3 times 4.2 gives me 22.26. All right, so 22.26. Now you got to be careful here because now remember the rule has to be one number to the left of the decimal or greater than 1 but less than 10. Well, 22 is bigger than 10, so I need to make a little bit of an adjustment. So I'm going to move this decimal right here between the 2's, and when I do that, since I moved it to the left, I have to add 1. So my final answer is 2.226 times 10 to the 16th power. All right, so see how it works. Okay, let's finish this up. Couple more. All right, so this first problem here, I want to know how many solutions are possible for this linear equation. Well, we need to do a little work first. Remember, our first rule says declare the parentheses with distributive property. Well, I have a parentheses here, so I've got to distribute this -2 to this parentheses, and I got to distribute this 1/2 to this parentheses. Well, let's do this side first, and since the other side has these numbers here. So 1/2 times 8, well, 1/2 of 8x is 4x. 1/2 of -16 is -8. All right, let's go to this side. -2 times a positive 2x is a -4x. -2 times a positive 5 is a -10, right? All right, we didn't do anything to these two, so let's write them down again. And now we can start combining our like terms. Remember, variables get boxes, numbers get circles. All right. So now on this side, we can't combine anything here, but if I look over here, I can combine over here. And remember, we talked about doing this. Take your pencil or take something and just cover up these two circles. What does that say? That says 8x minus 4x. Well, 8x minus 4x is 4x. And then do the same thing with the boxes. Get them out of your way. This says plus 3 minus 10. Well, 3 minus 10 is -7. So we have 4x minus 7 equals 4x minus 8. Well, if I look right here, box, circle, box, circle. Okay, so what I'm noticing here is I see that I have the same coefficients, but I have different constants. Okay, so before I even do any more work right now, if I remember my definitions, I know right now this is a no solution problem. But let's go ahead and finish it out. And really the quick, easy way, remember we talked about if these are the same, just cross them out. Because when you move one, they're going to be 0. And you're left with -7 equals -8. All right, and that is a false statement. -7 equals -8. So we have no solutions for this problem, which means there's nothing I can put in for this x, and this x that makes the left side equal the right side. So there's no answer. Okay, so the answer is not 0. Remember, the answer is no solution. All right, and then here are your perfect squares from 0 to 625. Remember, all we want to do here, if I was to ask you something like, where is the square root of 210? Well, if I look down through here, if I keep going, 210 is going to be somewhere between 196 and 225. All right, if I was to ask you something like, where's the square root of 8? Well, the square root of 8 is way back down here between 4 and 9, really close to 3, right? 4 close to 9, so be kind of close to 3. So just be able to put a square root somewhere on the number line. Okay? All right. Three expressions that are equivalent to r to the third raised to the negative fifth times r to the 10th. Well, before we do that, we got to know what this answer is. Well, we have a power to a power, which means I'm going to multiply my exponents. So 3 times negative 5 is negative 15, and then times r to the 10th power. Now I'm multiplying the same bases, which means I keep my base and I subtract, I keep my base and I add my exponents. Well, negative 15 plus 10 is a negative 5. All right. So one expression that's equivalent to that is, I could go really quick, is 1 over r to the 5th power, because remember, we can't have a negative exponent. This would mean the same thing. All right. But if I want to do another expression, what if we do a division problem? If I want to do division, if I'm dividing same base coefficients, well, remember, if I'm dividing, we're going to take our numerator exponent minus our denominator exponent. And if it to be a negative, that means my bottom number has to be bigger. So let's just say, what if I do something like r to the 20th power? Well, I want it to be negative 5. Well, 20 minus what gives me negative 5? Well, that's 25. Because 20 minus 25 is negative 5. I could do something like this. R to the 5th power, negative 5th, excuse me, times r to the 0 power. Remember, anything to the 0 power is 1, and 1 times this would be itself, or you also are adding. Okay, so anything like this that you can come up with that becomes out to be r to the negative 5th power. But don't worry, on your test tomorrow, you're going to have answer choices. So just be able to recognize first, you've got to understand what this answer is. Okay, all right, the last one, solving this this problem here. So if I look, the first thing I want to see is, I'm just going to start left to right. 7 squared, 7 to the 2nd power. Remember, this is not 7 times 2. This is 7 times 7, okay? So 7 squared is 49, minus the square root of 169, which is 13, plus 4, divided by the cube root of 8. Well, this was saying, what number can I multiply times itself 3 times to get 8? Well, the cube root of 8 is 2. And then 2 to the 3rd power, so this is just really the reverse of that, is 8. So the bottom down here, I know 2 plus 8 is 10. 49 minus 13 is 36, plus 4 is 40. 40 minus 10 is, I'm sorry, look what I just did, sorry. 40 minus 10, I apologize, 40 minus 10, 40 divided by 10 is 4. Okay, all right, so I believe you guys are going to do awesome tomorrow. I mean, I really do. You guys have been working super hard on all the activities we've done, and I look forward to seeing the grades. Good luck. Please study tonight, and please remember, there is a hard copy of this answer key without the videos over in the Unit 2 resource packet under the Unit 2 resource tab. So under the far left, up under the actual study guide itself. Okay, so check it out and study hard, and see you guys tomorrow. Good luck.